Ever heard of Old Faithful? I'd be surprised if you hadn't. Yosemite National Park is home to more than half of the geysers in the world, and Old Faithful is probably the most famous of those. You're watching it right now erupt to a height of about 180 feet. People from all over the country, from all over the world, come to see this amazing spectacle. And it's called Old Faithful because not all geysers are so easily predictable as this one is. In fact, most of the time the Park Service can estimate the time it's going to erupt to within about 10 minutes. Historically, the average time between one eruption and another has been about 75 minutes. But as we're going to see in a moment, it's not as simple to predict as you might think, and being able to do so relies on some skills that we'll need from 191, particularly the scatter plot. When you look at the data, you might get the idea that Old Faithful is a really inappropriate name. I've got a little chart here that tells you how many minutes pass between one eruption and the next eruption for a series of about 112 eruptions. And if you put these in a different kind of graph, one that, by the way, there's a template for on your website called a dot plot, you can see exactly how erratic this appears to be. Here, every time there's an eruption, we put a dot over top of how long it was in terms of its rest time. So this one came 45 minutes after its predecessor, this one 50, and as you can see, we've got times between eruptions anywhere between about 45 minutes up to almost 110 minutes. At best, you could call it sort of old semi-faithful, since there seems to be a lump somewhere around 90 minutes and another lump somewhere down here perhaps around 58. So how can the Park Service estimate the time until the next eruption with usually a 10-minute accuracy and be right? Well, the answer is that they're looking at more than just how long the eruption was. You might not know how geysers work, I don't know that much about them, but the idea that seemed to make sense to me was that, well, basically, you've got a bowl full of water that heats up. When it gets hot enough, water comes shooting out to the surface. And when it does that, you have a geyser. After a while, you shoot out all the water, it stops erupting, the bowl down there has to refill and reheat. So it seemed to me that if you had a long spouting geyser, you'd also tend to have a long rest period afterwards. That means I want to look at two pieces of data, not just how long the interval was between the next burst, but how long the preceding eruption was. Here we had an eruption that lasted 285 seconds, followed by a rest time of 87 minutes. I'd like to figure out if we can use the eruption's length to predict the rest time. Because I'm trying to use column B to predict column A, it makes a little more sense to put column A after column B. So I'm going to grab the whole column and just drag it over here to column C. I'll get rid of the old column A. And now I know how long was the preceding eruption, followed by how long was the rest. These two numbers go together, and I'm trying to see whether there's a relationship. Anytime you have two pieces of numeric data, two numeric variables, and you're looking for a relationship, one of the best things to choose is a scatter plot. Let's take a look. I'll choose the headings and the entries, highlight all of this data, and then we'll say, of course, insert, and now again a scatter plot, this dotty one that we see up here. I just want X and Y dots. Here's the picture. The horizontal axis, which I should label, but I'm going to save a little time in our class here, is how long the eruption lasted in seconds. The vertical axis, how long the rest period was. In fact, let me stop the video for a moment and put those in. There we go. And as you can see, the picture definitely suggests that there is a relationship, pretty much a linear or straight line relationship. The larger the eruption duration, as we may have suspected, the longer the rest time that follows. So what the Park Service can do is to approximate this straight line and find an equation for it. You'll have a lot more to say about this in 291 where we talk about this topic in detail, but let me show you basically what you can do to get a pretty good idea of what's going on. I'm going to find the best straight line in Excel by clicking on any point in this chart, right-clicking and saying Add Trend Line. I want it to be a linear trend line, a straight line, and that's the default choice. And down at the bottom I'm going to say Display the equation and display the r-squared value. That's all that I want, so I can close out of this. And right here in this box, you can see it's given me the information that I want, along with a dotted line on the picture that shows me where the best line is. Let me make this a little bigger so we can see it more easily. There we go. Okay, what's this mean? Well, first of all, the r-squared value is always a number between 0 and 1, and it's basically a measure of how well that straight line explains the data. In a sense that we'll be talking about later in this semester, the R-squared value tells us here that about 87% of the variation between eruption times, rest times, how long one rest is in another, can be explained in terms of the preceding eruption duration. The last 13% of that variance is explained by something else that we don't know about. We'll be more specific about that later too, but that's a pretty strong correlation, a pretty strong relationship. The equation up above tells us that x is the eruption duration in seconds and y is the rest time. So for any particular eruption duration, for example 150 seconds, I can plug 150 in for x in this equation, crank out the answer, and find out where that dotted line would be. It would tell me, for example, for an eruption duration of about 150 seconds, I would expect a rest of just about maybe 63 minutes or so. And that's the kind of thing that the Park Service would predict. So long eruptions, they'll predict long rests, according to an equation very much like this. So they just keep a logbook and make the appropriate scatter plot. Scatter plots again are a wonderful tool to allow you to see the relationship between two numeric variables. Between two numeric variables, it's the first thing you should look at in terms of an exploratory data analysis.